Okay, so in the previous lesson we looked at solving logarithmic equations, and today we're going to look at solving exponential equations. Okay, so we have looked at solving exponential equations before, right? Basic ones, and we've more specifically looked at the ones where the bases can be made the same. So in the example I have here, 2 to the power of x equal to 4 to the power of x plus 3. What we would have tried to do in the past is we would have said, well, if I can equate or make the bases the same, then I can equate the exponents. So we try to change all the bases into the same thing. So we have base 2 and base 4, and I know I can convert base 4 into base 2. So this will remain the same. I'm going to change 4 into base 2 squared. Right, and this is raised then to the power of x plus 3. So we're raising a power by a power. So we multiply the exponents. So here we're going to get 2 to the power of 2x plus 6. Now that we had the bases the same, we could equate the exponents. Okay, because if the bases are the same, whatever's the exponent must also be the same. So we got x equal to 2x plus 6 and x equal to minus 6 as one of our solutions. Okay. Now what we're going to do is look at what if the bases are not the same and we can't make them the same. So in the very first example we have 3 to the power of x equal to 40. Now what we would have liked to do is convert 40 into base 3, but 40 can't be converted into base 3. And so we need a better technique for solving, right? So what we're going to do is we're going to log both sides. Now you can use any base. It's preferable to use logs with base 10, right? Or later on you're going to learn you can also use the natural log. And the main reason behind this is just convenient. You've got log base 10 as a single button on the calculator, so you don't have to put a different base in every time. So what I'm going to do is I'm going to log both sides. And it's implied if I don't put the base that the base is 10. Okay, so this is going to become log base 3 to the power of x equal to a log 40, right? So just like an exponential equation where we can equate the exponents, right? We could, right, say we could drop these logs because if these two sides are the same, then, and they're the same base, then what's the value of the logs must be the same, okay? So from here, we're going to use the power rule. We're going to drop what we're trying to solve in front. So x is going to go to the front. Log 3 equal to log 40. And this is quite simple. We just divide both sides by log 3. And now we can solve for x. Okay, so in the calculator, make sure you use the same base. That's why using log is nice. Use the log button. So we're going to go log 40. Right, and we're going to divide that by log 3. And my suggestion is just write a couple of the numbers out, 3.3577, etc. Right, and then you can round to 3 significant figures. Okay, in the next example, we're going to do the same procedure. So we have 5 to the power of 2x plus 1 equal to 200. Again, the bases are 5 and 200, and we'd like to convert 200 into base 5, but we can't. And so what we're going to do is we're going to log both sides. Again, we can choose any base, but for simplicity, we'll just use base 10. Right, log 200. Now, intuitively, you can see when we're doing this step, we're always going to be dropping the power down to the front using the power rule, and so you can actually skip this whole line if you want and go straight to the next step, is where we would drop the exponent down to the front. This is then log 5 equal to log 200. Okay, we can expand this bracket out, so we're going to get 2x log 5 plus log 5 equal to log of 200. Okay, we can take the log 5 to the other side, so we get 2x log 5 equal to log 200 minus log 5. Now, the temptation would be to simplify this using one of our log laws. So this is two logs being subtracted with the same base. However, you're going to see in a minute that that's kind of pointless because we're interested in the answer and not simplifying. If we were asked to simplify, that would be a different story. But we're not being asked to simplify here. We're being asked to solve. Okay, the only thing left with my variable is this log 5 and this 2. So I'm going to divide both sides by that. So x is then equal to log of 200 minus log 5 all over 2 log 5. Okay, now if we were asked to simplify that, we could simplify that, and we could also bring this up as a power, but we want the answer, so we're just going to punch all of this into the calculator to get what we want. So we're going to stick log 200, and we're going to go minus log of 5. Usually the best thing here to do is push equals, right, and then divide by 2, push the log button, 5, and then you will get 1.14601, etc., which we can round to 3 significant figures, which is 1.15. All right, let's move on to a more advanced problem. Okay, so here we have an equation. It's an exponential equation, right? And we're asked to solve. Okay, and the problem is what we're trying to solve is all over the place. Okay, we have exponents in 2 of the terms, and we have a constant term, and so we can't move anything over to one side and log both sides because it's just going to be messy. So there must be another way, right? So what we need to remember is we actually need to remember our laws of indices. Okay, so if we remember our laws of indices, more specifically either the multiplication rule, where if we multiply exponents with the same base, we can add the indices. Alternatively, if we think about a power that's been raised by another power, that can be simplified as with multiplication, a times b. All right, so in our example here, let's just take this equation and say 3 times 2 to the power of 2x minus 2 to the power of x plus 1 minus 8 equal to 0. Okay, what we're going to do is we're going to manipulate the term slightly to our advantage. Okay, if we have a look at this term here, right, this can be compared to this law of indices over here, where if we have a power raised to a power, we multiply the bases. And what I'm going to do is I'm going to split them back up. So this is going to become 3 times 2 to the power of x squared, right? So if I had to distribute that back using my laws of indices, I'd multiply 2 by x and get 2x, okay? So what I've done is I've isolated 2 to the power of x, and then I've raised that all to the power of 2. And what I'm going to do is I'm going to try and do the same thing with the next term. So here I have 2 to the power of x, but I have this plus 1. And that is similar to this law here. So when we multiply powers with the same bases, we add the exponents. So I'm going to split those guys back up again. So I'm going to get minus, right? This is going to be 2 times 2 to the power of x, okay? Because this is 2 to the power of 1. These are two bases, all right? Or 2 values with the same base. When we multiply them, we can add the exponents. So if we added x and 1, we'd get x plus 1. So I've just split them up again. And then we're going to get minus 8 equal to 0. And what you can see now is what we formed is a quadratic equation. Here's my x term, okay? And so what we can do is we can either do this intuitively, or we can do the let 2 to the power of x equal y. And so you'll get 3y squared minus 2y minus 8 equal to 0. All right, and now we can just factorize. So 3 is a prime number, so it can only be 3 and 1, right? And now we need to consider what number do we add with from 8, right? And it's most likely going to be 2 and 4 to get minus 2, and so we'll get 6 minus 4. So 6 or minus 6 plus 4 will give me minus 2. Right, and I can continue going. So y must be equal to minus 4 over 3, or y must be equal to 2. And now we just need to remember that y wasn't y, it was 2 to the power of x. So we can replace that and we can say 2 to the power of x must be equal to minus 4 over 3, or 2 to the power of x must be equal to 2, right? On the left-hand side here, we have something raised by x to give us a negative number, and so this is undefined. Right, and on the right-hand side, this is 2 to the power of x equal to 2, which is actually just 2 to the power of 1, and so x must be equal to 1. Okay. Now, what we could have also done is we could have just gone straight there from here, and we could have factorized this as 3 times 2 to the power of x plus 4, 2 to the power of x minus 2 equal to 0, right? And we would have got the same thing. 2 to the power of x equal to minus 4 over 3, or 2 to the power of x equal to 2 to the power of 1. So same solutions, just either you can use the substitution method where you substitute the thing you're trying to solve with an easier variable, or if you can see it and you can do it intuitively, you can just go straight there.